This is lesson 5.2. So in lesson 5.1, we looked at angles in standard position in quadrant 1 only using the coordinate grid. And today we're going to be looking at angles in all 4 quadrants of the coordinate grid. I'm using something a little bit different for our notes today. I find that I don't particularly like the notes in the workbook, so I've made my own set of notes that are a little bit more condensed, and it'll take us a little bit less time to go through them. So make sure you have a copy of this first of all, so that you can follow along with me. First thing we're going to do, since we're working with all 4 quadrants today, is talk about how we label our quadrants. So just as a quick reminder, this is the coordinate grid. This is the x-axis. This is the y-axis. And when we draw an angle in standard position, we consider the positive x-axis to be 0 degrees. And then we calculate our angle based on how far away we are from that 0 degree line. So when we make it to the y-axis here, this would be 90 degrees. So you should be labeling this as well on your grid. If you go all the way to the negative x-axis, that would be considered negative or 180 degrees. Halfway around a circle is 180. Adding another 90 there, if you're at the negative y-axis, that would be 270 degrees around the circle. And then all the way back to the beginning would be 1 complete circle, so 360 degrees. Okay, so that's where we lie. So like, for example, if I was doing a 150 degree angle, this is what it would look like. So 150 degrees is between 90 and 180. So it would look something like this. Here is 150. Okay. One other thing about the quadrants here, we give them numbers to just refer to them quickly. So each sort of quarter of this coordinate grid is given a number. And we start with number 1 in the positive x and y axis, just because those are the smaller angles there. That's considered quadrant 1. And then we just go around clockwise as our angles get bigger and bigger. So this would be quadrant 2, this would be quadrant 3, and this would be quadrant 4. Okay, so that's labeling the quadrants. We're going to see angles in all 4 quadrants today. The second thing that we need to look at is a key term for today. This is one of the main key terms we're going to learn today, and that's what's referred to as a reference angle. The reference angle, the definition of it is it's the acute angle that the terminal arm makes with the x-axis. Let me show you what that means in all 4 quadrants here. So I'm going to do 4 examples, one for each of the quadrants. So the reason we didn't have this term in the previous lesson was because when you're working in quadrant 1, the reference angle is actually the same as the actual angle. So let's say our angle was 40 degrees. The reference angle would be that as well. The reason why we need a reference angle is because often we want to do trigonometry on these angles, and we want to create this nice right triangle here. And so the triangle that we create, that reference angle is going to be in the corner of it. Let's say we're in quadrant 2, and I'm going to give an example. Let's use the one we just did previously, 150 degrees. Just as a quick reminder, this is 0, this is 90, 180, this is 270. So 150 would be in quadrant 2, right about here, 150 degrees. Now the reference angle is going to be the angle with the x-axis. So we want to be doing trigonometry on right angle triangles using these angles. And so we're always going to create a nice little right angle triangle with the x-axis here. So my reference angle is going to be this little guy in here, in the corner of that green triangle. The way you calculate it is you just use those base angles that I've drawn in black there. So we take 180 and so we subtract 150 and we get what's remaining, which would be our reference angle. So in this case, it would be 180 minus 150, which would be 30 degrees. So the reference angle would be an acute angle. It's always going to be less than 90, and it's going to be the angle in the corner of that triangle. Let's see what that would look like in quadrant 3. this time, let's say I am doing the angle 250 degrees. So let's label our base angles again, 0, 90, 180, 270. So 250 would be in the third quadrant. Okay. And we want to create that nice little right triangle so that we can do our trigonometry later on. And we're always creating that right triangle with the x-axis. So my reference angle would be here. So the way I would calculate it this time, so the entire angle is 250 degrees. So I would take 250 minus 180, and I'm going to get what's left over, which is the reference angle. So just going to use the right color pen here. 250, oops, got a 0. 250 minus 180, and that would be 70 degrees. So this little angle in here is 70 degrees. That's my reference angle, and I would use that when I'm doing my trigonometry on the right triangle there. And finally, when we're in quadrant 4, here's how it's going to look. Let's label our base angles here. We've got 90, we've got 180, and we've got 270. So let's say we're doing the angle 300 degrees. I want you to try and draw that and figure out the reference angle. You can pause the video here and then press play again when you think you've got it. Okay, welcome back. So 300 would be just past 270, would be about here. And we want to create that right triangle with the x-axis. So here's my right triangle there. So my reference angle is going to be the angle with the x-axis right there. And the way we would get it was we would take 360, which would be all the way around, subtract off how far I've gone so far, so 300. So it'd be 360 minus 300 would be 60 degrees. So it would be 60 degrees. And I would use that when I'm doing my trigonometry. We'll see that in a minute. Okay, so that's the idea of a reference angle. Today, when you draw your angle in standard position, you could be in any of the 4 quadrants, and you're going to create this little green right triangle, no matter which quadrant you're in, at a acute angle there, which is called a reference angle. Okay. The second thing we're going to go over here are the third thing, the primary trig ratios. We already talked about this last day, but I'm going to just review it here in quadrant 1, and then we'll talk about how this changes when we're in quadrant 2. So let's start on this is our angle here. We talked about being at a point, x, y, and then we talked about these distances here, these lengths of our right triangle last day. If you need to review this more, you can go back to lesson 5.1. Sorry, I'm just going to make these lines straight. It's bothering me. There we go. That's a little bit better. There we go. So this horizontal distance is x, the x value of the point there. This would be y, and then we called this hypotenuse r for radius. Okay, so I have to remember my mnemonic device, SOHCAHTOA. If you remember SOHCAHTOA, you don't need to memorize anything else really. So let's write an expression for sine theta, cos theta, and tan theta in terms of x, y, and r. And again, I'm going to just make sure the pen's working. Okay. And again, I'm working with, pen stopped working here. Let me hold on 1 second. Okay. And I'm working with this right triangle here, and I'm using this angle here. So sine is, we can look at SOHCAHTOA, it's opposite over hypotenuse, so it would be y over r. Cos would be x over r, adjacent over hypotenuse, and tan would be y over x, opposite over adjacent. These little formulas are going to stay the same no matter which quadrant we're in. So let's say we're in quadrant 2 now. So I've got, let's say, an angle that looks something like that. Now, remember what we're going to do is create this little right triangle with the x-axis. And let's just label all of these lengths. This one is going to be x, And remember that since we're in the negative part of the x-axis, this is going to be negative. This will be y still. Actually, maybe I'll use the same colors so we're consistent. This will be y, and this will be r. Y will be positive because we're in the positive part of the y-axis. And the radius is a length, so it's always positive. I'll write that here, always positive. Okay, so here's our reference angle. I'll call it theta r. Okay, so sine theta, cos theta, and tan theta will have the same formulas. So this would be opposite over hypotenuse, so still y over r. This would still be x over r, and this would still be y over x. And then one thing to note, since x is negative, these two ratios are going to be negative. So the signs of the ratios actually can be positive or negative depending on which quadrant you're in, depending on if the x or the y is negative or not. And so we're going to learn a little rule later about like which ones are negative in which quadrants, but just keep that in mind. You could have negative values for your trig ratios or positive values for them. Okay, let's do a little quick example to see if we can remember what we've learned so far about reference angles and about the trig ratios. Okay, so it says given a point, determine the trig ratios and the angle. So here's a point, -2, -4, and it's on the terminal arm of an angle in standard position. So part A is what are the primary trig ratios, and part B is determine that angle. Okay, so if you want to try this on your own, you could pause here and try it. I'm going to draw. So in this chapter, you should almost always, for every single question, draw a picture of what's going on. Otherwise, you're going to be totally lost. Almost every question, you want to draw a picture. So -2, -4 is in the third quadrant. Let me label the quadrants here. 1, 2, 3, 4. -2, -4 is right about here. Actually, it's a little bit over. Maybe here. There we go. So here is -2, -4. And we always want to draw that right triangle. Okay, so let's label the sides of that right triangle right here. So this would be -2. The y value would be -4. And the radius would be the square root of -4 squared plus -2 squared. It's always going to be a positive number. And that would be square root of 20. Yes. And we can actually reduce that or simplify it, write it as a mixed ratio. Pull out the 4, and you'll have 2√5. You don't need to do that, but we're going to do that here. Okay, so now let's write our trig ratios, sine, cos, and tan. Sine is opposite over hypotenuse, so y over r, so it'd be -4 over 2√5. We can reduce this fraction to -2 over √5. Okay, cosine would be adjacent. And we're talking about, remember, this is the reference angle here, so we're using that to label the side. So it'd be -2, so the adjacent over the hypotenuse, which is 2√5. We can reduce it, cancel out those 2's. And then tan is opposite over adjacent, -4 over -2, which actually reduces to +2. So we can see here the sine and cosine ratios are negative, and then the tangent ratio is positive. Okay, and then part B is like determine what this angle is. So we can use any 3 of these, but what we're going to do is just use the tangent one. And I'm going to figure out what the reference angle first is. Remember that we're doing the trigonometry on this small green triangle. So when we calculate the angle, we're just going to get this little acute angle here. And then from that, we'll figure out the actual angle theta. So I'm going to be figuring out the reference angle, and I can use the inverse tan function. So it looks like that on your calculator. And I'll type 2 because 2 was the tan ratio. So if we do that on our calculator here, I'll open a new one. And I'm just going to make sure I'm in degree mode. You should always do that. Okay, and then I'll type tan minus 1 of 2. So that'll give me the reference angle. When you use the inverse tan, cos, and sine buttons, they're always going to give you an acute angle. So you just want to use, that's going to be your reference. So 63.4 degrees, and we're rounding to the nearest degree. So it'll be about 63 degrees. And I use squiggly lines because I've rounded this off. So, okay, and so then the actual, so that was the reference angle only. But the actual angle theta would be 180 plus the reference angle. It would be all of this plus that extra piece. So it'd be 180 degrees plus 63, which is 243. Okay, there you go. So there's how you use a point to determine your trig ratios. They could be positive or negative, and then you can use the inverse sine, cos, or tan button to calculate the reference angle. I recommend using the positive one because sometimes when you plug in the negative one, you'll get a negative angle, and that can be a little bit confusing. So I always just choose the one that's positive to do that. Okay, next question. You might want to pause here and try this one on your own, or you can do it with me. It's up to you. But we're going to try the same thing with this point, 0, 1, because this one's a bit of a special case. Let's see what happens. I'm going to draw my axes here. Okay, I'm going to write down my little 180, 270. So 0, 1 happens to be right on the y-axis. So let's label some things that we know here. The y value here is 1. The length of that line is also 1, but the x value is 0. This is a bit of a special case because you actually can't draw that green triangle because there is no triangle to draw. It has no kind of width to it. So let's see if we can still write down the trig ratios though, and you actually can. Cos theta, tan theta. If we remember the little formulas we came up with, sine theta was y over r, cos theta was x over r, and tan theta was y over x. So let's plug those in and see what we get. And it actually is consistent. So sine theta would be y over r, so 1 over 1, which would be 1. Cos theta would be, let's draw this, 0 over 1, which would be 0. And tan theta would be 1 over 0. If you try and divide by 0, you actually get something that's undefined. I'll show you on the calculator here. If you go 1 divided by 0, it's undefined. You can also try typing this in, tan of 90 degrees, and it'll also say error or undefined. So that's how you calculate the ratios when you're like on one of the axes. You can just use those formulas, y over r, x over r, and y over x to figure out what the values of the ratios are. Okay, let's go to the next page here. We've got a couple more examples and one more rule to get, two more concepts to get through. The cast rule. So what we saw in this previous example was that some of the ratios were positive and some were negative. The cast rule helps us decide where the trig ratios are positive and which ones are negative in which quadrants. So here's the cast rule. The reason it's called cast rule is because we're using the letters C, A, S, T in that order, starting in quadrant 4, C, A, S, T. And the letter tells you which trig ratios are positive in that quadrant. So if we're in quadrant 4, for example, C, the cosine is positive in this quadrant. The other ones are all negative. In the first quadrant, A stands for all, so all ratios positive. That symbol means greater than 0, so positive. In this one, S stands for sine, so sine theta is going to be positive. And then in quadrant 3, T stands for tan. Okay, so let's see how we can use that rule to answer some questions. Okay, so let's say, given that cos theta is negative 4 over 5 for an angle in standard position, determine the other primary trig ratios and determine the possible values for theta. Okay, So first thing you want to do when you're given a question like this, when you're given a ratio, so here we are told that cosine theta is negative. So I'm going to just redraw my little cast rule. This is what I always draw for myself when I'm doing a question like that. C-A-S-T, cast. And since cos is negative, I know for sure I'm not going to be in quadrant 1 or 4 because those are the quadrants where cos is positive. In quadrant 1, they're all positive, and in quadrant 4, cosine is positive. So I know I'm not going to be there. I know I'm either going to be in quadrant 2 or quadrant 3. It could be either one. So I'm actually going to have two sets of answers, one for quadrant 2 and one for quadrant 3, since cosine is negative in both of those. So when I do part A, I'm going to kind of split it up into two answers. Quadrant 2, let's draw how it would look. And remember, you always want to draw a picture in this unit whenever you're answering a question. So my angle would look like this. Here's theta. Here's the reference angle. I'll call it theta reference. And here's my little green right triangle. You always want to make that with the x-axis. Okay, so cos is -4/5. So let's label some stuff here. Cosine is x over r, or adjacent over hypotenuse. So the -4 would go there, and the 5 would go there. We can use the Pythagorean theorem to find the other length. This is the 3, 4, 5 triangle. So that length would be 3. You could also use the Pythagorean theorem to find it. Okay, so let's write our ratios then. Sine theta, cos theta, we already know that, but I'll write it again, and tan theta. So SOHCAHTOA. So sine theta is going to be opposite over hypotenuse, so it'd be 3/5. Cos theta, we already know, it's adjacent over hypotenuse, -4/5. And tan theta would be 3/-4. Okay, there we go, done. Quadrant 4. We're actually going to get the exact same ratios, except in quadrant 4, I already know the tan ratio will be positive based on cast, and the other ones will be negative, but we can draw it out anyways. So here's my theta this time. Here's my triangle. Okay, this is -4. This time, the y value is negative because we're in the negative part of the y-axis, and the radius is 5. So I'm going to have the exact same ratios, except my signs are going to change. Sine this time is -3/5. Cos is still -4/5. That's given in the question. And tan is -3/4, but the negative signs cancel out. -3 over -4 cancels to 3/4. Okay, so that's how you write. So there's two sets of answers. You could either have, for example, for sine theta, you could have +3/5 if you're in quadrant 2, or you could have -3/5 if you're in quadrant 4. So this is how I recommend writing out your solution. Okay, and for part B, we're going to have two answers as well. So we're going to determine theta between 0 and 360. So I could be in quadrant 2 or quadrant 4. So let's just start with quadrant 2. And remember, you use the inverse button. And I typically like to use the positive ratio, so I'll use sine. So we're going to find the reference angle, sine -1, so the inverse sine of 3/5. And this is going to be a decimal number. I'll open a new calculator here. I don't know why it turns black, but. And we're going to make sure we are in degree mode. Okay, so I'm going to go sine -1 of 3 divided by 5. And I get 37 degrees approximately. So then that would mean theta would be 180 minus that reference angle. So it would be 180 minus 37, I don't trust my mental math, 143. Okay, in quadrant 4, I would get the exact same reference angle, so no need to calculate again. The reference angle is still going to be 37 degrees, but this time my primary angle would be 180 plus 37, right? Because we were gone 180 and then another reference angle further, so it'd be 207 degrees. So I have two possible answers. Or sorry, 217. See, I knew I didn't trust them. 17 degrees. There we go. So two possible answers for theta, one for quadrant 2 and one for quadrant. I labeled quadrant 4 there. It's actually quadrant 3. Sorry about that. One for quadrant 3. Sorry about that, guys. Okay, there we go. Depending on which quadrant you're in. Okay, last concept here, special triangles. So let me just look at this example that we just did again. We got approximate answers for our angles. So for most triangles, most side lengths, you're going to have an approximate angle. But there are two special triangles that if you have certain side lengths, you're going to get an exact answer. And these we call them special triangles because it's the only two. And you have to memorize these. So when you have these certain side lengths, you're going to get an exact answer when you see these ratios. Okay, so the first triangle that has an exact answer is the 45, 45, 90 triangle, when both acute angles in your right triangle are 45 degrees. So what that means is the two legs of the triangle are going to be the same length. So if they were 1 and 1, then the hypotenuse would be square root 2. So if you see these side lengths, 1, 1, and root 2, then you know you have a 45, 45 triangle. Okay, and then the other one is a 30, 60, 90 triangle. So this is where the smaller of the two angles is 30, and the other one is twice as big, it's 60. And what the side lengths are here, actually, let me keep my colors consistent here. So 60, 30, there we go. The ratios of the side lengths are 1, 2, root 3. So it's nice and easy to remember because it's almost like counting to 3. 1, 2, root 3. 1, 2, root 3. And the way that I like to remember where to put the numbers is this. So the root 3 always goes next to the 30. It's on the leg next to the 30. So the 3 is next to the 3. That's kind of how I memorize it. And then the 2 is the longest of these three numbers, or the largest of these three numbers. So it would, of course, go on the hypotenuse. And then the 1 goes on the leg next to the 60. 1, 2, root 3. So these are the two special triangles. When you see these numbers in a ratio, you know you're going to have a special triangle. And so you can actually get the answer without even using your calculator. So let me show you how we can use these special triangles to do some of these questions. So let's do this question here. It says, determine the primary trig ratios for the angle 330 degrees in standard position. So always, 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 when we start a question, we want to draw a picture. Okay, and let's label our kind of base angles here. This is 0 or 360, this is 90, this is 180, and this is 270. So 300 is between 270 and 360. So I'm going to be in this quadrant, quadrant 4. And so this would be 330. 330 is 30 degrees away from 360. So the reference angle here would be 30 degrees. And here's my right triangle, my green right triangle that I create with the x-axis. So I have a special triangle here, 30, 60, 90 triangle. So I can actually label the sides without even knowing any other information. I know that the three sides have the following lengths. It's 1, 2, root 3, remember. So it's 1, 2, root 3. The root 3 is always next to the 30 degrees. And I'm going to make sure I have the right signs here. So we're in the negative part of the y-axis. So this 1 is going to be actually a -1. The radius is always positive, and then we're in the positive part of the x-axis. So the root 3 will be positive. Okay, so let's write our SOHCAHTOA sine. Actually, we can, instead of writing theta, we'll write sine of 330 degrees, cos of 330 degrees, and tan of 330 degrees. So sine will be opposite over hypotenuse, so -1 over 2. Cos will be adjacent, so root 3 over 2 over hypotenuse, and tan is opposite over adjacent. There we go. So just from one of these angles, if it gives you a special triangle, you can write down the ratios, the three primary trig ratios, without it knowing any other information. Okay, let's try another one where we'd use special triangles also. Okay, so this question says, given that sine theta is 1 over root 2, determine the other primary trig ratios and determine possible values for theta. And we're not even going to use a calculator for this because we're going to use special triangles. Okay, so when you're given a ratio, first thing you want to do is use that cast rule. See, I didn't need to use the cast rule in the last question because I knew it was in quadrant 4, given that the angle was 330. But this time we don't know the angle, so I don't know which quadrant I'm in. So I need to use the cast rule to figure that out. So sine is positive here. So that means I'm going to be either in quadrant 1 or quadrant 2. I'm not going to be in these two where sine is negative. So we're either going to be in Q1 or Q2. Okay, so I'm going to have two sets of answers. Let's say I'm in quadrant 1. So we always draw a picture. Okay. And my triangle will look like this. Here's theta. In quadrant 1, it's kind of nice because the reference angle is the same as the angle. X, Y. And let's label the side length. So sine is opposite over hypotenuse. So this is root 2, and this is 1. Let's scroll up to our special triangle there. Root 2, 1, 1, root 2. Oh, look, it's a 45, 45, 90 special triangle. 1, 2, root 2. So this would be 1 also. So I know automatically that theta is actually 45 degrees because this is a special triangle. So I already have part B done. And then I can write sine, cosine, tan. Sine, I already know that one, 1 over root 2. Cos is also 1 over root 2, and tan is 1 over 1, which is just 1. Okay, let's say I was in quadrant 2. How would that look? Always draw a picture. So this time I'm going to be looking like this. Here's theta. Okay, and I'm going to have similar lengths. I'm still going to have that special triangle, the 1, 1, root 2 triangle, the 45, 45, 90. Well, I need to reset my pen again. Okay. There we go. So I'm told sine, which is opposite over hypotenuse, is 1 and root 2. So I'll also have 1 here, but this time the x, we're in the negative part of the x-axis, so the x is going to be negative. And then this is the reference angle, which is going to be 45 degrees here. Okay, so sine theta, cos theta, tan theta. Sine is opposite over hypotenuse, so 1 over root 2. We already knew that. Cos is adjacent over hypotenuse, so negative 1 over root 2. And tan is 1 over negative 1, so it's negative 1. And this time my actual angle theta, we know the reference angle is 45, but theta itself would be 180, which would be all the way to that x-axis minus the reference angle. So it is 135 degrees. Okay. So when you have a special triangle, the key idea is you don't need your calculator. You can actually, all the angles and the trig ratios will be already set for you because we already know the side lengths of those special triangles. So when you see one of those 30, 45, 60 degrees as one of your reference angles, you know you've got a special triangle and you don't need your calculator. Okay, so that is it for the lesson. I'm going to pause it there.